Okay, this is the second take because I accidentally deleted the first one. We're going to finish answering Kristen's question in class. It's the third one. It is probably the harder of the three. Um, so since I've already done it and hit the wrong button, I'll walk you through what I've done again. So I'm first going to visualize this with maple cast. And I've already put it in. And you can see as I move this, I made it so I could put washers based on left-hand Riemann sums. And you can see there's a washer. Okay? You can see that. And that's what it is. So here we go. The first thing I did was I graphed the region. Okay? So when I graphed the region, I went ahead and I put sample points in the region. The only thing that's going to change are the y values, which are the individual heights above the x-axis. The distance from the x-axis to the line of rotation is 6 units. I'm going to let my inner radius be r1. So my inner radius plus y1 must be 6. I solve for the radius, 6 minus y1. I do the same kind of thing for the outer radius, r2. Now, I pull my cross section out. Draw it. Since if I was to extend it, it would hit the x-axis. I'm integrating an x. Then to make this an easier problem, because if I give you a problem like this on a test, I'm testing setup. Everything I've done right here, I expect. I also expect you to use and communicate effectively the use of technology. So I'm going to tell you I'm going to let f1 be x squared. I'm going to let f2 be 4x minus x squared. My outer radius was 6 minus y2, which is 6 minus x squared. My inner radius is 6 minus y1, which is the quantity 4x minus x squared. You can tell this is getting ugly. Imagine what happens when I go to square that, because that's a radius. So I would use technology to test this. I'm going to use these to make the area of the cross section easier, because the area of the outer disk will be pi times the quantity 6 minus f1 of x squared. The area of the inner disk would be pi times the quantity 6 minus f2 of x quantity squared, which I did over here and I ran out of room. I then set up my integral. Notice I followed that same notation. Since I have communicated it up here, if this is the calculator part of the exam, they read with you. I get 64 pi thirds. We have it. We're done.